Hello guys, this is Juan Saco from Exploit Pack, and on this video we're gonna start the series of crackme from learning reverse engineering from crackmes to exploit. So basically the intention of this series is for you to learn how to do reverse engineering and how to apply the reverse engineering using IDA or Ghidra or GDB into exploiting in the process of exploit development using, of course, Exploit Pack. For this purpose, of course, we're gonna start with the crackmes. I'm gonna show you first with the IDA. Particularly on this video, is gonna be focused on IDA, and on the next video we're gonna try to do something similar, a little bit more advanced, using Ghidra, and then mix Ghidra and IDA, and then also do it with GDB as well. But of course my preferred disassembly program is IDA. For me, at least, is my favorite one. It's the one I like to work with. But we're gonna start this journey. So I guess you can start with a version that you can find on the internet, or the free version directly from Xtrace, or you can try to do the same on your favorite disassembly. So all right, so let's begin. All the crackmes are I'm gonna be taking them from crackmes.1, and then of course I'm gonna facilitate you guys with some fuzzers that I wrote myself, and also with some binaries that I know beforehand they do have a vulnerability. But for the moment, we're gonna start with crackmes. I'm moving to exploiting and finding vulnerabilities in programs. It will be maybe in 1 or 2 videos ahead. So I already got these two. This is the 2 crackmes we're gonna do. We're gonna start with the easy peasy. So basically, in IDA we choose open IDA, and then you have to choose if you're gonna use 32 or 64 bits. In this case it's 32 bits. I open it, then it's gonna ask me. I'm just going ahead through the basics because I assume that you are not familiar with crackmes or reverse engineering or even this program. So if you are familiar and you are more advanced into it, and you just want to learn how to do exploiting and apply reverse engineering into the process of exploit development, then you can just skip a few videos. Otherwise, you can just go ahead and try this by yourself. Well, I choose open it with IDA, and I just notice that it needs to be used on a 64 bits. So let's go ahead and open it on IDA 64. All right. It's asking me because it's asking me if I want to load the symbols, because it has some reference to symbols. Sometimes the reference are not realistic, and sometimes they are really references. In this case, I accepted the reference, and as you can see here on the function name tab, it autocomplete the subroutines with all the signatures and the reference from symbols that it found. So we have a standard string and so on and so forth, standard batch, standard string, standard manifold, and others. So here you will see all your functions. IDA is gonna try to find all the subroutines and assign a proper name from it. It find it based on signatures. If not, then it's gonna on this case is adding a name to them. If cannot find the subroutines, then it's gonna say sub, and then the memory offset of that subroutine in particular. You will see that maybe on others that doesn't have symbols in other crackmes. Below that, we'll have the graph overview where we can choose navigate into the binary, in a more graphical way. If this is the view A of IDA that I'm clicking and setting the focus on. Below that, we have the output window where we can access the IDA Python directly from here. So we can say print hello world from here, right? And then choose send it to IDA Python. We can also access IDC, that is IDA script language. For instance, if we want to access that, we can set this breakpoint, set a breakpoint, and then do like edit breakpoint here, and then set a condition, and then we can choose from here IDC or Python. Yeah, we will use that later on to set registers into breakpoint and modify flags in the fly during runtime. But at the end, we will see here a few tabs. IDA, as I said, IDA view A, then we can have, of course, more than one. And then we have the strings window. Yeah. And then from there, then also we have the X view. We can use this, and then we can also synchronize there with the windows that we want. We can modify it and save directly here the binary, structures, enums, imports. There are also some other important views that you might want to have, like signatures. Yeah, and in this case, it just detected the signature for this binary. So it's Visual C 64 from 7 to 14. And then another one important to have is segments. Yeah, and then we can see all the segments. This is particularly important when we try, for instance, if we want to unpack a binary, and then we want to take a snapshot of the segments that are created during runtime, then we can do it here. And then from the debugger, we can take a memory snapshot and then load or remove segments, or modify segments or export segments. You can do it from here. Even if you want to add one, if you want to create a code game or something, then you can also do it from here as well. Exports, this is what the binary exposes, and then maybe something more important as well is the name functions. Here we can see all the function names that we have for this binary, this particular binary. So we can start debugging it from here. Yeah, the binary. Of course, I'm running this on a virtual machine. You can see it's this is it's a Windows 10, right? Yeah, this is running inside a virtual machine on a VMware workstation. I'm running it here, so it's a Windows 10. So basically, I can run this binary. I don't have internet connection, so I can run the binary. It's in a secure lab, in a secure control environment, and then just revert to snapshot and go back from where I began. So this is a really easy crackme. So how do we start with a crackme? Well, first, if I just made some changes in the window, so I can save here the desktop and then save to default, because IDA will have two different views, one for the disassembly part and another type of framework, another type of desktop, let's say, for the debugging part. So right now I should save the configuration that I like for the disassembly part of it. Well, I forgot to mention that on top here I can go through all this graphical part of the binary. Here I can just scroll through it. Like all these are the sections. I'm currently moving my mouse through the data section. Here's the text section, so you can see that the .text section is the most biggest one, and all the black part is like not assignated space to it. And then from here data, then I go here data. But if I go to the Promax section, I can also move like that. If I want to go to BSS, then I can just go here, right? So if I go to text, then it will take me there. All right. So I know it's gonna be a Windows program. It should say it's here. So it's a host type Microsoft Windows. Application type is a portal executable. So I can go ahead and select the debugger. In this case, it's gonna be a local Windows debugger, press OK, and then from there I can start the process if I want it. If I want to set breakpoints, then I can also have in my disassembly view, I can have a breakpoint list here that I can see on my disassembly view. So I will also save this. And also something I always like to have during crackmes is to have a notepad for this database. So again, save it, leave it like that, and then the next time I open IDA, I will remember my changes, and it will have all these tabs open for me. IDA works in databases, so basically everything I do here is now loaded in a database. I can also export the database, I can add scripts to the database, take database snapshots. It works just like VMware snapshots or something like that. So I can share this database with another reverse engineering, and he can also take a look into it. Besides that, it's something really nice to do, because if I'm sharing a malware sample, then I don't have to share the binary itself, but I can share the database. So that's a bit more secure. Well, then we have the edit here. The edit tab here, or tab menu. Sorry, not tab. It's a menu. And from here we can add the plugins list with all the configs for the plugins, the other windows, where sometimes you have something there when you are making a plugin, or there are some manual instructions. There are some stuff that didn't belong anywhere, so it goes into other patch program. This is something you might use during crackmes. So if you want to patch a crackme, for instance, if you want to jump like it's debugger present and you want to actually patch that, then you can assemble that program. So for instance, let me show you. If I go somewhere into a function that belongs to the binary, I don't know, here, and I want to patch this, then I can just go ahead and say patch program assembly, and then change this sham fopen to say set fopen, and then I should change it. You see it here, and then if I want to apply it, then I have to go ahead and say apply patch to inputs files. Yeah, then I can also create a backup. So it will create a backup on the machine, on the path that I choose. Yeah. Also, something useful is to go here and do patch bytes, and then I can also revert those. Revert. Do you want to revert the patch? Yes, and also this one. And then I just change it back to jump. But because I didn't apply, if you want to run it and in the debugger see your changes actually happening, then you have to apply those patches, otherwise it will not happen. Functions, structures, segments, if you want to choose, like I say, comments, if you want to edit comments, or for instance, if you want to add a comment here, I can say this is a comment, and then it will go and put a comment there. I can choose remove the comment like this. Well, there are other ways to add comments. I will show you when I do the compilation of this one. Jump search, if you want to search text, opcodes, or anything you like. Different types of jumps, you can jump from all these different ways. Views, you even have a calculator that is really useful. For instance, you do like this. Oh, sorry, I didn't show how to open the calculator. I just open it with the shortcut. So calculator, this is the shortcut, and then you can also open it like this, and it's really useful because you can do like 41, and then you say decimal 41, hexagonal, this character is it is this, and then you can say A, no, should be 41H or 40 or H41, something like that. I never remember how to actually do that, because you can also convert it from here. For instance, now it's showing 90 hexadecimal, and you can also you can always convert it directly with IDA. So let's go back to the strings and start doing this crack me. So from the strings I see a say please log in with your credentials, username. Now please insert the password, get the fuck out your name as hacker. Alright, that's kind of rude, but okay. Or you have successfully logged into the system, so I guess that's more polite. That means that you on this case you were able to, yeah, you see here's the window that you don't, the part of the condition that you don't want to reach, and this is the one that you wanted. So we can go ahead and click here on the window color and set it up on green, because that's where we want it to go, and then this one we can set it up on red because that's not what we wanted to go. And from here we can see we have a sham that's we can set up auto comments and jump if not zero. Oh, sorry, again, I did it too quick. So options general, and then you can set auto comments, and then it will out all the auto comments for each opcode for each line. Also, if you want to see the stack pointer line prefix, you can also add it from there, right? Alright, so from here now we can see that it's gonna add please insert the password from here, and then it's gonna call std out from the stream and do count. That count is like a printf, but for C++. And then he's gonna do another stream, but in this case it's gonna accept the stream and it's gonna read it and set it into a variable. It's using here this is out, this is in. Well, basically this is reading a variable, and then it's gonna set that variable. First it's gonna call it, and then for the stream, and then it's gonna set that variable into somewhere, I guess, yeah, these two, yeah, this one, because it's setting the stream. So basically it's making the call, and then it's setting, yeah, setting it up, and then yeah, these are the arguments. So I guess we can set a breakpoint here and then run the program. Press F9, yes, I accept the risk, say name 1, and then we are here. And then if we go further, no, I guess he's hitting something. One, but before catching the breakpoint is exiting the program, so it might be that it's checking for is debugger present. So something we could do, it might be, I'm not sure. So something we could do is to check if loading is debugger present. I'm not sure. Let's check it. So how can we check that? We can go to here. I might just made a mistake with the breakpoint. I think that's all. We can press Ctrl F, and no, it's not there. And another way to look it up is when you are here, you can enter into the model. Well, I cannot access. Has no name. That one. Oh. All right. Well, anyway, let's set a different breakpoint. So on this one, let's put the breakpoint on the call, and then like that. Somehow is exiting this. All right. Well, I'm already seeing this, but I want to figure it out. So it basically is loading this specific address with this value and this one into those registers, and then asking for the credentials, and I guess comparing my input to those values. I think that's what it is so easy, but I want to figure it out why it's not taking my breakpoint then. Oh well, it's taking it. So I guess if we go like that, then I can access it. Right there. So this is what I'm sorry guys, this is what I wanted to show you before. So if you have the module Windows, this is the debugger window. Sorry, I forgot to mention. So this is the debugger window, and here we have the X view, the stack view, what's happening. You can also double click on here and then go there. This is quite useful. But more is, I think it's more useful doing exploit development, at least for me. And then we can see the threads, well, of course, all the registers and the flags. From here, the modules that are loaded during runtime, and if you double click on kernel 32 and we go to is debugger press, and we can look it up, and it's in kernel 32. This is the address, and we can go inside. If it's finding, if it's loading this one, then we can also set a breakpoint into is debugger present. That's, so we go there, and then you see this is from kernel 32, and this is the DLL, and we can set a breakpoint. And if he ever hits it, he's gonna hit it. I already have a breakpoint in is debugger present. Having in mind, I mean, if I don't know if it's the binary is gonna call is debugger present, this is just like a blind shoot. But of course, I can also look at the imports of the binary and the names, and then look if it's actually calling it or not. But you can also set different type of breakpoint from different protections that you think it might reach. It's like a blind shoot, as I said. Well, I know it's not gonna hit it because I already checked, so we can forget about that. So continue the execution, pressing F8, and then we can see here it's gonna ask for credentials. Now it's gonna call this, it's gonna create a stream, and then print a username. It's gonna show it in the screen, in the screen. That I'm going one by one. Now it's gonna ask for the username, so it's gonna check my username. So let's say 1, and then it's gonna load my username. All right. And now checking it. Yeah, it already checked that it's not long enough, so it's moving there because my the username that I use is not long enough. So what I can do, oh, by the way, you can, instead of following the disassembly through graphical way, you can also press space and they move to the text view, if that's easier for you to follow. IDA is also smart enough to add this type of comments, like starting this try. So username, and all right, here's my variable. Okay, basic stream. Now it's asking again. Let's do it like this. Yeah, because I already compared these two. All right. Specific address, small. Okay. Let me also look it up here. Well, if I press F5, what's gonna happen is it's gonna try to create the pseudocode that IDA understood this, and it's trying to create it, creating the variables, trying to make a pseudocode of so basically IDA, the compilation part of IDA X-rays, what it's doing is taking the assembly and making it a pseudocode for you to read, in this case C++. So as you can see, it's how we say before, is you have these two variables. I wonder how it feels to be a time traveler. This is one, and this is the other one. And then, yeah, it's checking this one and this one, that P7 is the user input. And we have B7, B8, and B9. All right. It's doing a locator for B8 and these two. All right. So username, if now please insert the password, and oh, you can also change here if you want, like if you want to change the variable name, you can press N and then replace the name of the string. So like on this case we can say username input, and then it will change, it will check it. And then on this one, that's the other one, we can say that is password input, and it's not going to only change it here, but also on the disassembly view of it, right? So you can see it's also changed it here, and as well here, for instance, it's calling standard out. This is the output. Please standard out, making the stream. Then this is the input. From here, this is where it's doing the read. We can add a comment here. Saving from reading username variable. Then if it's easier for you to read, then you can just have it a comment, and then you can add a similar comment here for reading password variable, and then like that, and then you have, so it's easier for you to read. And then it checks if the password input is equals to this, but as you can see, first you have to hit this condition. There is this if, yeah, this condition is if true, then you can go inside and then you have a nested if, and inside it, if you hit this if and it finishes as true, so basically if your password input is equals to the value of B8, that B8 is this, yeah, you can see here the string B8. So we can say, to make it easier, we can press N and say password, and then like that, type like that. For the username input, so we can say username, right? So now, so first it's gonna check the username input, so basically your input against the username. If you want to look at the values of those, we can also, you can place a breakpoint inside the decompilation part of it. So we can run it, and then this is the first breakpoint that we hit. And here again, if you want to see the breakpoint list, you can have it here, you can move it, like I also like to have it here. So as you can see, I have two breakpoints. One is called ABS, it's for the decompilation, for the disassembly part of it, and then on the source one. So if I double click on this one, it will take me here. I was already there, that's why I didn't check. But otherwise, if I click on the other one, well, you open it the pseudocode, but I can also move it here. And then, well, it takes me to the next breakpoint. So if I click run, I can say, well, I guess the first breakpoint is on the first condition, so I can say 1, and then it hits this one. And as you can see, this is a reference to something. So if I want to see the content, then I have to follow the reference. All right. I guess we can just go ahead and look at here the reference, and you can copy it. We can put it in the notepad, username, and this one should be the password. All right. We can now go ahead here and remove the breakpoint, or disable it. Why not? We can disable the breakpoint, and then click on play. And when it's asking me for the username, it should be this one. Oh, sorry. Okay, we choose moving to the second if, because now I hit now please insert the password. But before ending it, to see if it was correct, let's go there, set a breakpoint on the that's the input on the end of it. All right, and the return. All right. So hey, my space board is broken. Can you help me find it? Okay. And then like that, you have successfully logged into the system. All right. So we complete the first crackme. Let's close it. Let's start with the second one. So the second crackme is called Brainfuscated. It's made into with I don't know, I don't remember if 32 or 64 bits. I guess it's 32. So as I show you, the input file is also linked with symbols, but look at the symbols names, because I'm not gonna tell you anything. Get out of me, you lazy fuck. So I guess loading the symbols is not gonna be any help on this case. So again, we have the functions names, and you can see some of the functions IDA couldn't recognize. So this is called sub for subroutine, and then the memory offset. All right. And if you want to verify that, then you can do auto command like that, and you can see that the memory offset is exactly as the name of the subroutine. You see? All right. I have a main. Do I have strings? No. And as you can see, if I press F5, it's gonna look really sketchy, because this particular crackme is made with a program language, programming language that is called Brainfuck programming language. So Brainfuck is a exoteric program that it was created in 1993 by Urban Müller, and the program is called Brainfuck OBF, right? So this is a typical hello world program in this language. So well, basically someone made a crack me using this this programming language. So what we're gonna do now? Yeah, we cannot use the decompiler, so that's not gonna work. So what we could do here, you see we have put char, so we have to go into this assembly. That's the only way of doing this crack me. So something we can do, we can start like this, and then select local Windows debugger, play, yes. Alrighty, so we are here and it says S. It hit our breakpoint and added an S because it just went through put char. Yeah, so it's basically moving it and calling put char into it. So basically it's adding a char into the screen. So I guess we continue. All right. It's gonna go through all, and then let's hit the next put char. So basically let's remove this breakpoint and then click F9, and we're gonna go through all this loop and then finish up here, and let's see what we see on the screen. So 1, 2. So the first one is SEM. Let's continue to see what is gonna show in the screen, right? F9. Say simple pragma by Pelus Stitch. What's the key? All right, I don't know what's the key. So let's look into the strings to see if we have something there. I don't think we're gonna. I don't think we're gonna see anything. No, I just look into the string on real runtime. So no, there's nothing. All right. So this one's not gonna work. Too many. Let's see on this put chart. Let's see what's gonna show on the screen. Simple. Okay, so let's keep remove this one and let's go down like that. Continue execution. Simple pragma. Let's continue. Another one like that. By Pelus. Okay, I know at some point picture is gonna. This was autocomplete by IDA. It's not like I knew that call SE and then calling all these preferences. It was gonna work. It is IDA doing it. Huh? So by payload stage, so I'm just following what IDA is showing me. So we continue it like that. Okay, the next call to put char. What? Okay, at some point we're gonna reach the input of our variable, and that's where we want it to go. What's the key? We're almost there. So right. So there is no more char here. Get char. All right. So this is what we wanted. So we had put char and get char. That of course it's self-explanatory. And get char is what we wanted to reach. Okay, get char. Boom. Let's type 88. No, so far still didn't call it, so we need to go into this one. So continue. 1, 2, 3. Now is the input is allowable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So So okay, enter. Now we go ahead, and I guess it's gonna do this loop again. All right. Moving it. It's calling it one by one, so we can go like that until here. So I put a breakpoint here. Again, another one. And then it's gonna print a message after. So I guess the message is gonna be no, you did it correctly, or you did it incorrectly. So I guess we are close to the serial logic, if there is a serial or something. So those are my compare these A's. So those are my A's. All right, so this one, serial input. All right. Right, and what is this? This is not there yet. I know what's gonna be there, but it seems interesting. Okay, let's go ahead. So it's gonna do it for each A. All right, and then exit here. All right. So now I have it here. That's the pointer, and there you go. So basically, I think that's the serial. If I double click on it, I can see that here this is my input, and I guess this is the serial. So now I can go again, open Notepad, and then it's asking for what's the key? Key equal hyper. All right. So we can copy it. Well, first let's finish. If I press ESC, I will go back, or I can also do with the arrow like that. I prefer to press ESC, but you can also do like this or like that. Right, so continue. All right. So I guess now what I can do is to try to see. Well, it was comparing it, so it was comparing my serial against that value. So I can go to debugger, breakpoint list, and remove these two, stop the execution, running again. What's the key? And now it's running without breakpoints. So I can set a breakpoint at the end of it. Remember, we saw that after that it was gonna show some messages of put char, so we can put it at the end of it. All right, and then yeah, then hyper, and then congrats, you got it. So guys, I hope this was useful. Well, I think this I hope it was useful. You can find more crackmes in Cracksmiths 1, and also on exploit pack. If you if you open the tool exploit pack and you go into Maybe I can show you. I don't know if I have it open. No, no. If you open the tool and you go exploit pack, I mean if you go to the utilities window into the exercises, you will have two crackmes. One is called Dragon Crack, where you have to defeat dragon. It's kind of a RPG game where you have to defeat the dragon, and the dragon will fight back with memory anti-debugging protections. It's kind of funny. And then you have another one that is called crackme J1. That those crackmes are made by me. They are a little bit harder than these two that I show you to crack, but they are also easy to do. So on the next video, what I'm gonna show you guys is how to do some other crackmes a little bit more difficult than these ones, and also doing those in Ghidra, and looking also into Binary Ninja and what are the difference of those. After that video, we're gonna start doing exploitation, so basically creating the rope chain and doing a reverse engineering, finding a buffer overflow, but doing it from a reverse engineering perspective. So basically, after hitting a vulnerability into a program, we need to reverse engineer that program and find which particular function was vulnerable, why, try to go back, reversing the program, setting breakpoints, and understanding exactly why that buffer was overflowed and how was the workflow in order to reach that buffer, just like we are doing with crackmes. Right? So I think that's gonna be useful for you guys. And remember, if you have any questions, please join us the community of Exploit Pack in our Discord channel. And if you like this video, please leave a thumbs up. Or if you have any opinion or something about you want to share with the rest, just leave it at the section below. Thanks guys, and have a nice day.